Now, if you recall, this was the recovery unit for my reusable rocket engine. In this video, I'm going to show you the evolution it has gone since then. This elongated part is from the delay grain, but it didn't make much sense to me, so I removed it and replaced it with this one. It seems there is no delay grain here, but truth be told there is. I integrated it into the upper part of the first propellant grain. This didn't work well because it resulted in premature ejection charge firing. Then this final one came to me. I don't know how, but it makes all the senses for successful recovery. The unit is 3-in-1 device. The upper part is what houses the ejection charge, and in the center is a touch hole connected to a restricted orifice that I repurposed from a diesel fuel injector. The hole about 1 millimeter across serves as to fine-tune the ejection charge and to prevent the backward flow of gases. The restricted orifice is what houses the delay grain, which forms the smoke trail after burnout. Now let's go ahead and test it separately to confirm its operational status. Now, what would happen if the propellant grain gets integrated with the recovery device setup? Alright, thus but verify. I now attach an inch-length propellant grain as in the normal motor, and I was able to get a 40-second delay before the ejection charge fires. Now this is super long, but I'm alright with it because it allowed the vehicle to fall freely from apogee before parachute deployment. Premature ejection would damage the chute system, and if the chute comes out at the highest point, it will drift away by the wind. Now I'll go for a final static test, for which would involve the default 4 grain with an approximate total mass of 1043 kilograms, and see if I would get the 40-second delay as a constant time value for the recovery device. Until next time, stay safe.